If you want a technical platform that delivers your business aspirations and your business ambitions, it's crucial that you get your technical architecture right. It's also hugely powerful if everybody in the team can understand all the models and designs of a technical architecture and has a real appreciation of how it all comes together. In a previous video, I talked about why a technical architecture is so important to business success. But here, I'm going to talk about 3 fundamental principles that you need to formulate a technical architecture. Now, this video won't turn you into a technical architect, and it's not going to go deep into the computer science part of architecture. But what it will give you are new ways of thinking that will help provide you with a deeper appreciation of technical architecture. But for now, let's waste no more time. Let's get to it. So the first principle I'll discuss is that of defining the purpose. The starting point for creating an architecture is understanding what it's trying to achieve. It's understanding its intent. This may seem obvious or straightforward, but in my experience, this is not always the case. Many architectures I've seen are accidental architectures. And these architectures have basically been created by bolting on new pieces of functionality to an ever-evolving system. The problem with accidental architectures is that they may not be well aligned to the business needs and the business goals and objectives. This results in platforms that are not effective and fail to deliver the desired business outcomes. By answering that big why question, you can make sure that your technical architecture aligns to your business strategy. This all seems straightforward and it all seems like common sense, but there are pitfalls that you can fall into very easily at this important stage of defining the architecture. One of which is to bake in too many incorrect assumptions. I've seen instances where incorrect assumptions subvert the technical design and then lead to some really odd solutions. For example, we're only a small business, we're only a small brand, so therefore order volume won't be a problem, despite the fact of the primary business goal being that of accelerating growth. Another pitfall I see technologists fall into is that they will override the business purpose with a technology initiative. The purpose should always be focused on the business, not some technical initiative like building a more elegant, modern platform, removing technical debt, or trying to standardize the whole platform. Another classic pitfall I see everybody falling into is that of defining the solution rather than focusing on the problem. Don't get stuck on how problems can be solved, but instead focus on what those problems are and therefore understand what the architecture is actually trying to achieve. The final pitfall I see many big companies fall into is that of building a purpose from off-the-shelf packages. This is similar to the last pitfall, but it's more about having access to existing technology that already solve a range of problems, and then taking those range of problems and incorporating it into your purpose because it seems like a good idea. A great example of this is your kitchen like mine. Is it full of gadgets? Is it full of things that you thought, I need one of those, or it solves a problem I didn't even know I had? And years later, your countertops and your cupboards are filled with clutter, with great solutions looking for problems. Well, that's what your architecture can look like if you don't stay focused on the real business goals. One final piece of advice that I can give you when it comes to defining the purpose and the intent of an architecture is to use a hypothesis. This is because a hypothesis provides a clear and focused statement that can be evaluated against the business goals and actually provide a way of structuring research around the whole purpose. Let's move on to our next skill or technique, abstraction. Abstraction is about creating a representation of something we're trying to solve by filtering out the details that we don't need and then instead concentrating on the details that we do need. When discussing software development, abstraction is fundamental as systems become so complex that the level of details can become overwhelming. At the early stages of the software development project, details are not exactly precise, but it's still important to articulate different aspects of the system to both the business and the developers. And this is where different levels of abstraction or different levels of detail come in. Let me explain. I recently had the pleasure of assembling some flat pack wardrobes that I hadn't actually seen in real life because my wife chose them when she was out shopping. When it arrives, it's in different shaped boxes. It has sets of instructions, bags of fixtures and fittings, some simple tools like some Allen keys. And the first thing I do is I open up all the boxes, get out all the parts, and read the instructions. Yep, you've got it. I actually read the instructions first. The instructions were an abstraction. They take out all of the aesthetics, all of the finish, and really focus on the components and the stages of assembly. Frankly, what I struggled with throughout that assembly process was really trying to understand what the final product would actually look like. And this is because I hadn't seen a completed wardrobe, so I actually had to put in lots of assumptions to fill in the gaps in the abstraction. For another example, think of the concept of a bicycle being 2 wheels, a frame, and some handlebars. Now that abstraction could actually fit nearly every single bike that's out there. Now this level of abstraction is pretty useful to try and get everybody on the same page during a software development project, but it doesn't define that much depth in terms of pieces of functionality that will ultimately deliver the business goals. On the other end of the spectrum, you could have a detailed schematic that outlines every single component that makes up the bike. And that's going to be really useful for engineers to assemble that bike. And in software engineering, that would be really useful for programmers to build those components. But at that level of granularity, it may be too difficult to see how all of those pieces come together to actually solve the business problems. You could say that software development is a process of moving from a very abstract level to a very concrete one. And at each stage, providing different levels of abstraction or different levels of detail. So the next principle I'm going to talk about is functional decomposition or problem decomposition. You have the purpose of your architecture, and even if you've gone down the process of abstraction, actually building a system from those abstractions can be quite a daunting task. Fortunately, the process of filtering out all of the noise and all of the details during abstraction makes it easier for you to actually take a bigger problem and break it down into smaller problems, therefore allowing you to focus on smaller problems, which you can go through the same process again and abstract them and turn them into even smaller problems. And you can do that until you get to the base set of problems. This process of functionally decompiling things will ultimately lead you to identifying subsystems and components that are used to ultimately deliver the purpose of the architecture. Each of the components you identify own their own small part of the overall system, whether that's a feature or a function. You can start to understand the roles and the boundaries of these components. And at this point, you can even start to understand how the components are connected, how they interact, and how they communicate with each other. For instance, the components may be tightly bound, and that means that the components have fixed, dedicated integrations that cause very strong dependencies between the components. Or they're loosely coupled, which means that they're very independent and they interact through open standard interfaces, and that means they have very few tight dependencies between them. Using abstraction and functional decomposition is a very powerful technique for defining the elements of a technical architecture. By breaking down a large complex system into smaller manageable parts, it's easy to identify the components, the interfaces, and the interactions that go to build up the larger system and deliver the business requirements. Hopefully this video has given you a basic understanding of the fundamental skills and techniques you need to formulate a technical architecture. Whether you're starting on your own journey as an architect or just want to understand more about the thinking involved in technical architecture. Practicing these skills is frankly useful for all kinds of problem-solving tasks, as well as gaining that deeper appreciation for technical architecture design. And if you like this video and you found it useful, please take the time and press that like button so this video can be shared with many others. If you're interested in learning more about technology, about architecture, about Mac architecture, about composable architecture, and you like the level of depth that this video goes into, why not press the subscribe button or watch one of these playlists? But for now, it's time to say thank you, goodbye, and I'll see you next time.